These are the notes for lesson 11-3, the surface area of a pyramid or a cone. So something that comes to a point. So there's only going to be one base with these problems here. We are also dealing with regular pyramids. So if it is a five-sided base, it's going to be a perfectly shaped regular five-sided base. Or a four-sided figure, it would be a square base, not a rectangle base. But it would always be a regular figure where all the sides are the same. There's going to be two huge important uh, ideas here: an altitude or a height, how tall the pyramid is, and the slant height, which is the height on the edge, on the surface of the figure. Okay, so we're going to figure out those are the main two ones that we got to pay attention to. When we deal with the lateral area of a pyramid, we're going to notice that they're all triangles. Instead of rectangles with prisms where there are two bases, with pyramids where there's one base, you're going to see a bunch of triangles. All right, so we're going to go down here and fill in some of these vocab. This one here where it's pointing to the top is the vertex. This guy here where it's pointing to an edge, it says edge, but it is called the lateral edge. This one here, right underneath lateral face, is an arrow that's pointing straight down. Let me see if I can highlight this guy in red. From the highest point straight down to the gut of the pyramid, in the middle of the pyramid, that is called the height of the pyramid. And there's going to be a difference between the height and the slant height. And this edge here along the base is called the base edge. So there are lateral edges, which are on the lateral sides, meaning the sides that are not the base. And then, of course, there are base edges. All right, moving on here to the next picture. This guy here is the other key word. If you happen to be going from here to here, and they highlight it with the letter L, I don't know why they use the letter L, but this is called the slant height. And that is literally on the surface of the cone. In this case, this is a cone. This is called a right cone. It's not that big of why it's called a right cone. As opposed to that slant height, as opposed to this green line, which is the regular height. The regular height is inside the cone or inside the pyramid, and there's a huge difference. When we are talking about space inside, we're going to use that green line, the regular height. When we're on the surface area, which we're going to be doing today, we use this slant height because it's literally on the surface of that cone. And this looks like it's pointing to the base. Alrighty. So I'm canceling out this 11-3 picture here. There's nothing wrong with it, but I find that it gets people more confused when they put down these formulas for the lateral area or surface area of a pyramid, because all the pyramids could change, whether it's a pentagon, hexagon, octagon. So I don't want to just put down one formula. It just confuses people. So we'll skip that. And we're going to flip to the second page here. We're going to do number 1. I've already preset a net here for this pyramid here. But let's read the directions for number 1. It says find the surface area of the square pyramid with base edge 7.5 and slant height of 12. So you can obviously see the picture there. You want to realize that the base is this square, and it's not going to be a rectangle. It will always be a regular figure, so in this case a square. And so we can easily figure out this area of the square because it's base times height or side times side. And this 12, which is the slant height, which is on the surface of the pyramid. If I open up the pyramid, it would be from the highest point straight down 90 degrees with that base. And in fact, all of these slant heights are the same because this is a regular pyramid. So in order to figure out the surface area of this guy, it's basically the area of a square, which is 7.5 times 7.5 base times height, and then the area of a triangle, which is 1/2 base 7.5 times the height. Now the height in this case is the slant height of 12, and of course there are 4 of those. And boom, I got all of the calculations done already, and So the area of the square, area of one of the triangles, you can simply multiply by 4 because obviously there are 4 triangles here, or I can just go triangle 1, triangle 2, triangle 3, triangle 4. We're going to add them all up, and that would be anything exposed to the surface area, SA, 236.25 feet squared. Now moving down to number 2, find the surface area of a cone. Radius is 15, the height is 20. All right, so first thing we're going to do is draw the three-dimensional picture of a cone. I'll make a little oval there, and I'll make it meet to a point, thus being the cone. This is a radius of 15, and the height is going to be in the middle of the cone. Let me see if I can draw it. This will be 20. All right, we're going to want to draw the net. It is obviously in a two-dimensional world. It is simply a circle. Now, normally when we had a prism, or excuse me, a cylinder, we'd open up the middle and it would be a rectangle. This case, it's going to be a triangle. Well, that triangle's horrible. The area of the circle is not going to be a problem. The area of the triangle, we're going to have to do some calculations for. This red line, which is 20, is not the height of this triangle. We need this height from the highest point down to the base, which that green line is right here, the highest point from the tip down to the base 90 degrees. It is not necessarily here. Okay, that is not the slant height. The slant height is coming from the highest point, and you're drawing it. And if you open it up into the two-dimensional world, it would be right here. Okay, so we need that green height. If I look back at the original 3D picture, I've got a triangle here. I've got a 15, I got a 20, so it looks like we're going to need this slant height here, and we're going to do a squared, b squared, c squared. And then we're going to solve for c. Okay, I'm going to save us time here. C is 25, so that will be this portion right here, which is right here. This is the circumference again, which is 2 pi r. And so the area of the circle is pi 15 squared. The area of the triangle, is 1/2 base times height. The base is the circumference, and the radius is 15 on that, times the slant height, which is green, which is 25. Okay, and I cheated here, and I show all the calculations in advance here, but basically the area of the circle, I ran out of room, so I put it here. And then the area of the triangle, I put it down here. And then you add it all up, and you have the surface area. Basically, a circle and a triangle. But understand, when you open up that triangle, you need the slant height here in green.